Hi. The second method to calculate the distance in the UWB is a double-side two-way ranging. Double-side two-way ranging is a more precise and accurate than a single-side two-way ranging because here the distance will be calculated by exchanging the multiple messages. In double-side two-way ranging, there are two parts are there: four-way message exchanging and the three-way message exchanging. So I'll be explaining the three-way message exchanging method, and the code is corresponding to it. So in a three-way message exchange, the first message will be transmitted from the device A and it's record the transmitted timestamp. As soon as device B receives the message, it will record the received timestamp. Device B process the message and transmit back. Before transmitting back to device A, it will record the transmitted or transmit timestamp on the received message. And as the message goes to the device A, it will record the received message timestamp. Now difference between TX and RX gives the T round 1 and the difference between RX and TX will give a T replay 1. Once the device A receives the timestamp, it will again process the data and it includes its timestamp to the second message and sends back to the device B. Now here the device B do the final calculation. So total three messages will be exchanged between the device A and device B to get a final timestamp. So this called the double side two-way ranging. It's a more accurate method than a single side two-way ranging, but then the code complexity increases a little bit more. Same way we have four messages for the double side two-way ranging where the four messages will be transmitted, and you can increase the number of messages to get a more accurate, see, and it will minimize the clock offset between the two controllers. So I'll just walk through the code. This code will is a double side two-way ranging. The till the major difference in the double side two-way ranging is the messages where we define. In single two-way ranging, we have only TX pole message and RX pole message. But in double side two-way ranging, we'll be having one more message called TX final message. Final message will be transmitted from the device A to device B. Similarly, in the receiver, we are having a RX pole message and TX pole message, same as the single side two-way ranging, and a final message, RX final message, where the final calculation will be happens. And remaining settings are similar as a single side two-way ranging only. So setup also not much difference. We can directly go to the loop. So in double side two-way ranging, even though initiator sends the first message, but the final calculation happens at the receiver's side only. So this is a device A transmitting the first message, and as it's transmit the first message, the logic goes to the device B, where device B is ready to receive the message. As soon as the device receives the message, the full receive flag will be enabled. Then it decodes the message, then it validates, compares with the predefined message. It compares the first couple of bytes to make sure that received message is proper and from the authorized device here. After that, it starts process the data, adds the time delay to it, and sends the message. That is this part. Here, and the data message goes to the device A. We'll be coming back to device A responder to transmitter. And here the device A receives the message transmitted on the device B. Then it processes the data, extract the timestamps from the received message, and here instead of calculating the timer flight. It again it's embedded its own timestamps and sends back the final message to the device A. Now again the control comes to the device B where it is already waiting for the second round of transaction where the message will be transmitted back to the receiver for a final calculation. It will receive the final message and it will process data and it will check some validation with the predefined final message, initially couple of bytes, like first 10 bytes. Then it start extracting the timestamps from the received message and calculates the final distance. So here the final distance will be calculated on the receiver side, that is a device B side. So if I open the serial plot, right now you can see the distance between anchor and tag is 55 or 60, 56 centimeters. So now this is the anchor, this is the tag, this is the device A, this is the device B. The final calculation happens at the device B. As we are moving this device B near to the device A, you might have seen that there is a distance is decreasing, the graph slowly comes down. As I'm moving further, the distance increases. And it takes some time to get stabilized. And this is already double side to where engine is working.